Hi, in this video we're going to find the minimum or the maximum point of a quadratic graph in a particular context, in a particular modelled context. So we've got some equation here that finds the height of a ball, h. H is the height of the ball above the ground when it has travelled a horizontal distance of x. So x is the distance, and if we substitute the value of x, that will give us the height of the ball. So for example, if the horizontal distance traveled was 0, we'd substitute 0 into this, and that would give us a value of 2.2, so the height would be 2.2. And you can see indeed, when x is 0, the horizontal distance is 0, the h will be 2.2, the height above the ground. And we want to find the maximum height reached by the ball during its flight. Well, we can see the maximum height is at this point here, and we want to find this maximum height here. That will be the y value. That will be the y value of this coordinate will be that height, basically, because the y value gives you the distance above the x-axis, doesn't it? Now, we previously saw to find the maximum or the minimum point of a quadratic, we have to complete the square. So let's do that. We're going to write h is equal to, now always put the x squared term first, so minus 0.045 x squared. Then we're going to put the x term, so plus 0.72x. And then finally the constant term, so the plus 2.2. Now, whenever you want to complete the square where there's a number in front of the x squared, the method you use is you have to first factorize out the number in front of the x squared out of the first two terms of your quadratic. So we're going to factorize out the minus 0.045 out of the first two terms. And then we'll leave the last term, the third term, on its own, just minding its own business. So if we do that, factorize it out, well, minus 0.045 times what gives you that first term? Well, it's just x squared. We can see an expansion, that will give you that first term. And then minus 0.045 times what is the 0.72x. So I'm going to have to use my calculator for this. 0.72 divided by negative 0.045. And that gives you negative 16. So you get negative 16x here. If you just check that, this times negative 16x will give you that 0.72x. And then the next step is that you complete the square inside that bracket. So I'm just going to copy everything outside the bracket first, and then complete the square inside that bracket. So I'm completing the square with this. And the way you do that is you halve the number in front of the x. So you halve that. So half of minus 16 is minus 8. So you open a bracket, you write x, then that half number, minus 8, close bracket squared. And then that half number, you square it and throw it away. So the minus 8, you square it and throw it away. So minus 8 squared is positive 64, and then you just subtract it. And then the last step is that you expand out the outer bracket, not the inner bracket, the outer bracket. So I'm going to do the minus 0.045 times this first term in the bracket, so the whole of that bracket, x minus 8 squared, which is just minus 0.045 x minus 8 squared. And then I'm going to do this number on the front times the second thing, so the minus 64. I definitely need a calculator for that. So minus 0.045 times by negative 64 gives you positive, and if I do that as a decimal, 2.88. And then I've still got that plus 2.2 on the end. Let's just tidy up. We're going to get h is equal to minus 0.045 x minus 8 squared. And then if we add these two, 5.08. Right, okay, so we completed the square. It's a slightly awkward one because we had decimals, but we do have a calculator. And then remember how we then get the turning point, whether minimum point or maximum point, from this completed square form. What we do is that whatever the number is after the x in the brackets, you negate that and use that as the x value of your turning point. So we negate this, and the minus 8 becomes positive 8. And then the number after the squared, so the constant term, the plus 5.08, you just use that, you copy that as the y value of your turning point. So that just stays as positive 5.08 8. So that means we've now got the turning point, in this case, the maximum point of this quadratic. It's 8, 5.08. And as I said earlier, the turning point, with the maximum height, sorry, is going to be the y value of this turning point. So we can see that this height is going to be 5.08. And that is the answer. It's 5.08.